Hello everyone, back tuning into the 6th Winter 2016-2017 update from GavsWeathers.com. So since the start of September, we have been doing the winter updates on a week-by-week basis. Every Sunday, we've been releasing a new update. We're up to update 6, so we're beyond the halfway point now. Got more of these to get through for the remainder of the autumn. We're going to run up to the end of November with these updates. And then we're going to release the GavsWeathers.com Winter 2016-2017 forecast at the very end of November or the start of September. I haven't got the date on that for you yet, but interesting and exciting news on that, because this time next week, I will release the date of the GavsWeathers.com Winter 2016-2017 forecast. So you'll be able to find out next week in the 7th update when the GavsWeathers winter forecast is going to be released, the exact date for that. We've also done the seasonal model updates, of course, as well. We've done one of those in September. We've got another one to come in a couple of weeks where we get all the long-range models together and see what they are showing. And what these updates are doing, maybe not all that obvious as we go on every week, but this is all building up to the winter forecast. So each one of these updates is an interesting update in its own right. There's always a lot of sort of information, important information contained within these winter updates, but they also make up a bigger whole because each one of the updates is an important part of where we eventually arrive at, which is the winter forecast. So we get our methodology together, like solar activity, like how quickly snow coverage advances across Russia, sea surface temperature anomalies, what ENSO is doing in the Equatorial Pacific Ocean. We get it all together, and on a week-by-week basis, we see how these drivers are progressing in terms of building up the picture for winter forecast. So that's not always that obvious what we do here on a week-by-week basis, but each one of these updates is very important in its own right and also in terms of the winter forecast. So we're going to do a 6th update in a sense. It'll be quite a long video, so if you can't watch it all in one go, don't worry. It will be placed on the winter updates page later on today, and have a written post to go with it. So you can watch the video on demand whenever you want on the winter updates page. There'll also be that written post. You can't watch the video all in one go. And also to say about later on this afternoon at website, we are going to do the ECMWF seasonal model interpretation. That's going to be really, really interesting. I'll talk about that at the end of the video, but watch this space on that one. Right, before I get on with the 6th winter update, just to say about the ads, there's links to articles on all the pages. Have a browse, widgets, and click through the links. If there's any articles that you're interested in, you'll be helping us to pay for our website. Thanks so much for doing that. There's also video ads on most pages, which open up content. When you watch them and close back up again, it does help to pay for GavsWeathervids.com. And I've got anything else, so I think that's just about it. So I'll get on with the 6th winter 2016-2017 update. We're going to start off with solar activity. So this is the solar disk on our side of the disk today from solarham.net. And officially, solar activity is at low levels, as so often through these winter updates. Very rare, but we're saying anything other than low or very low in terms of solar activity. We have got some sunspots. We've got one just here. We've got quite a big one over here and also one on the eastern limb. Notice how many of these sunspots are congregating around this equatorial region of the sun. Now, that is something that you tend to get when you approach and then come out of solar minimum. When you're in solar maximum, you tend to get the sunspots in the northern and southern hemispheres. They tend to be very big sunspots as well. When you approach solar minimum and then come out of solar minimum, you tend to find the sunspots more through this middle part of the solar disk, and that's exactly what's going on at the moment. Usually there aren't all that many of them, and they are congregating and fairly weak and congregating through that middle part of the solar disk, and that's what we've been seeing quite a lot of just recently. So solar activity at low levels right now. Let's see how things have progressed over the past week. So this is the latest Gavs Weatherby's Winter Update Daily Solar Activity Tracker that's being sent through every week from our good friend James Ackland. I know James will be watching. He'll be watching the update today, the 6th update. Big thanks to James, as always, for updating and sending through the Gavs Weatherby's daily solar tracker. So this is where we are right now in terms of sunspot numbers. We are just here. That's the very latest, that orange spot just there. What's happened over the past week is that we've seen a decline in sunspot numbers. If we go to last week's tracker, this was it. That's where we was when we did the 5th update last week. We was moving upwards in terms of those sunspot numbers. Since then, we have come down. So we was around there through the early part of this week, but now we're down here. Looks like we're in a more declining period just at the moment in terms of those sunspot numbers. Over recent months, we've had quite a few periods where there's not been any activity, such as back here in June, and then again a few days in July. Not much since then. We did get one day at the start of October that didn't have any sunspot numbers. But it looks like we're going back into a declining phase once again. Solar activity is quite weak now. We are moving towards solar minimum. We're not there yet, but that's certainly the direction we're heading in. Notice solar flux is also beginning to trend downwards again, indicated by that pink line. And this green line just here, that's also edging down a little bit as well. So overall, it looks like everything is starting to move downwards again, or has been moving downwards again during the past week. Now, the reason we look at solar activity is because when the sun is weak, when it's not doing much, it doesn't have any sunspots, that tends to coincide with an increased risk of blocking in the UK and for Europe. It's there's less of a connection for North America and also for Asia, but for the Atlantic and for Europe, and that includes British Isles, of course, there is a connection there between low solar activity, weak sunspot numbers, and, excuse me, also an increased risk of northern blocking. So when you get solar minimum, you tend to enhance the chance of colder winters, and especially as you come out of solar minimum for 2 or 3 years. We're not in a great phase at the moment of the colder winters in this declining period, because we're still unravelling the solar maximum. That did occur quite late this time as well in 2014. So it was a very weak solar maximum. There's a caveat about that. But these periods where we decline from maximum to minimum, they're never all that great for colder winters. But it doesn't preclude the chance of cold winters, particularly in a solar cycle like this that is so very, very weak. We'll see what the solar tracker is doing next week. Let's deal with the oceans next then. So this was the sea surface temperature anomaly for the world when we did the 5th update last week. 3 areas that we're interested in specifically. We've got the Northern Atlantic over here, we've got the Northern Pacific over here, and then of course we've got the equatorial part of the Pacific Ocean just here. That's the ENSO region from Peru to Indonesia. That's how things were looking this time last week. So it was warm in the Northern Pacific Ocean, or the Northeastern Pacific Ocean, cooling down in the Northern Atlantic Ocean, and edging ever so slightly more towards weak La Nina condition through the equatorial Pacific. Let's have a look at the latest, and this is it. Very little change in the north, so dealing with the northeastern Pacific first. That still remains very warm up there. We're going to have that through the winter. That's not going to go now, I don't think. So again, it could be another winter. We'll have this for about 3 winters in succession now. It'll be another winter where we're going to have to deal with this warm water up here. This has been tending to coincide with colder winters in America because it tends to send the jet stream down across the northern part of America like that, which introduces cold air, of course, from Canada into much of the north of America. And when that cold air reaches the Atlantic, of course, just here, it can blow up the jet stream and sweep the jet stream through across the Atlantic Ocean. I think we're also going to have a cooling Atlantic because this cold water in the Northern Atlantic Ocean appears to be expanding. If we go back to last week, that situation last week, this is situation now. Not much difference, but it's perhaps expanded ever so slightly. We don't have a tripod. If we want negative NAO, i.e. blocking, then we want warm and cold and then warm in 3 bands like that. We don't have that. We did the NAO forecast back in the summer, of course, and we said probably wasn't going to have a tripod this winter. I don't think we are going to have a tripod. So the North Pacific, the North Atlantic, not ideal, excuse me, for colder winters. Now, in the equatorial Pacific, this is how things were looking last week. This is how things are looking now. And again last week and again now. Very little change through this central part. We've still got some colder water, surface water there. Just on the threshold of either being in a weak La Nina or ENSO neutral. But over here in the eastern part of the equatorial Pacific, actually we're seeing a little bit of warming compared to what we had last week. Now, keep in mind that situation last week again, that situation now. Keep in mind, this area is quite shallow water over towards Peru, so it is more prone to changes in sea surface temperature anomalies, of course. But what this could be in response to is what's been happening with the SOI, because in the past week, the Southern Oscillation Index has done this. Now, Southern Oscillation Index is a reflection of the state of the atmosphere in the Southern Pacific Ocean between Darwin in Northern Australia and Tahiti in the central Southern Pacific. When the SOI is positive, when you've got positive numbers, it's telling you that the atmosphere is reflective of La Nina. When the SOI is negative, it's telling you that the atmosphere is reflective of El Nino. Remember, it's always the weather that's driving the indexes. Same with the North Atlantic Oscillation, same with the Arctic Oscillation. It's always the weather that drives the index, not the index that drives the weather. So what we see, or what we have been seeing over the past few days, is that we've had some very negative numbers. Now we should be getting positivity. We're going to have La Nina, which is the cold event. We should be getting numbers like this, plus 11, plus 12, plus 10, and more than that, maybe into plus 20, plus 30s. What's actually happened since we did the 5th update, so it got increasingly negative. So we had on the 9th, -2, on the 10th, -2, on the 11th, -5, on the 12th, -13, on the 13th, -18, going more negative all the time. On the 14th, -25 is the number that we have. That is very reflective in terms of the atmospheric setup of El Nino. So over the past week, the atmosphere has been reflecting El Nino. We can see that through the SOI. While the ocean is still trying to produce a La Nina. The cold water is there in the central part of the ocean, but the atmosphere is fighting against it. Had a lot of this over the summer and into the autumn, which is the reason we've not been able to generate a La Nina event. So this warming just here could be in response to the atmosphere going more towards El Nino over the past week. And in any case, whilst we're getting such negativity of the SOI, we are not going to get into La Nina. We might be able to sustain sort of a very weak borderline La Nina event, but we're not going to be able to get into a proper La Nina. And we may, if this negativity was to continue for several weeks, we would probably go towards ENSO neutral, maybe even by the end of winter towards weak El Nino. That's quite speculative, of course. Reason we look at the ENSO region in particular is because there is a connection between weak La Nina and an increased chance of a colder winter. We explored that in the earlier updates and checked those out. Haven't seen them yet, but it's weak La Nina that we want for a increased chance, not a guarantee, nothing is guaranteed with UK weather, but for an increased chance of a colder winter, we want a weak La Nina. We are barely at La Nina at the moment. QBO next, quasi-biennial oscillation. And we know the QBO is doing something very unique and unusual. We should be in the easterly phase of the QBO, which is indicated by these white zones just here. We should be in easterly QBOs. What's actually in an easterly QBO, what's actually happened is that we tried to start an easterly QBO just here at the start of the year, and it failed. The westerly QBOs on these charts are indicated by the darker areas. The westerly QBO hung on and just kept going, which is something that has never happened before. We've never seen this back to 1950, anyway, when we first started monitoring the QBO. We can't say if it happened before then, but certainly back to 1950, we have not seen this occurrence with the quasi-biennial oscillation. Now, when the QBO is westerly, it tells you that the zonal westerlies, the strength of the zonal westerlies around the northern hemisphere, is enhanced. When the QBO is easterly, it tells you that the zonal westerlies are weakened. So the fact that we have gone or continue with westerly QBO perhaps goes against the chance of a colder winter. Very hard to say that, though, because it's a unique occurrence. We haven't had this happen before, so quite what the impacts of this are going to be, I'm not sure anybody can really say. Now, this is how the QBO chart looked from the University of Berlin website back in September. I got this from the weatheroutlook.com, the forum there at weatheroutlook.com. This is how the QBO looked back in September. Let's see if there's been any changes over the past month. This is the latest. And very little, really. I think you'd say it's more or less the same. Again, going back to middle of September, going back to the latest. Very little difference. The westerly QBO, indicated by this dark area, is still going down to around there. This, of course, is the levels of the atmosphere. The easterly QBO is still in the lower levels, but the area where weather is taking place is further up. So we are still more or less in a westerly QBO. I thought maybe the easterly QBO had expanded a little bit over the past couple of weeks. I don't think it has, really. We are still in the westerly QBO, and I would have thought likely to at least be starting the winter in a westerly QBO. Whether we eventually, through winter, transition easterly, I'm not sure, but certainly for the start of winter, I think we are likely to be in a westerly QBO. But we can't say what the impacts of that are going to be, really, because it is such an unusual and unique event that there's nothing to compare it to. So let's just wait and see on that one. I'll do more about the QBO in November. Hurricane activity next. We have seen a further increase in tropical Atlantic storms. So far for the 2016 hurricane season, we have had 15 total depressions, 14 total storms, 6 hurricanes, and 3 major category 3 or above hurricanes. This is now the strongest hurricane season since 2012. We can say that quite definitively. We have beaten 2013, 2014, and 2015. It's the biggest, strongest, most active hurricane season since 2012. I'll show you what 2012 looked like, actually. That year, we had 19 depressions, 19 total storms, 10 hurricanes, and 2 major hurricanes, category 3 or above. So in terms of the major hurricanes, we have actually passed 2012. But in terms of total storms and total hurricane numbers, we are still some way short of 2012. Nevertheless, this will be the most active hurricane season since 2012, and we look at this because what hurricanes are doing, essentially they're one of the Earth's thermostats. So they take the heat out of the tropics and they transport it, and same with typhoons in the Pacific, by the way. They transport the heat and distribute it across the planet, and eventually that heat will finish up in the polar regions. And when you get lots of hurricane activity, lots of storms, dumping lots of heat in the polar regions, it can translate back later on to an increased chance of blocking, and particularly that blocking might be on our side of the pole. If you get lots of typhoons in Pacific, that can dump heat on the Pacific side of the pole, you see what I mean? And that can translate back to an increased risk of blocking the Northern Pacific. But for us, it's the Atlantic hurricane season that we look at. And there could be a connection. This is a Joe Bastardi theory, formerly from AccuWeather and now at, now at Weatherbell. It's a Joe Bastardi theory, and I think there is certainly a connection, anecdotally anyway. I haven't looked at it in huge depth, but I think anecdotally there is a connection between years that have active hurricane seasons and then later on a chance of a colder, more blocked European and Atlantic winter. So, biggest hurricane season so far since 2012. I don't think we'll beat 2012, but quite interesting how many storms we have had so far. Don't normally look at this. This is Arctic sea ice extent. Don't normally look at this now, but something quite interesting has happened there. This green dashed line is the death spiral in terms of Arctic sea ice loss that occurred in 2012. I'm going to put in 2016, which is this red line. So, of course, we reached our minimum of the Arctic sea ice loss just here in the early part of September, after which we saw the red line creeping back up, so the refreeze did begin. But notice what's happened over the past week or so. The red line, instead of moving upwards like that, as you would not expect it to do, the red line has actually sort of flatlined. Been a very, very slow pull out of the Arctic sea ice extent, i.e. the refreeze. It's been very slow to get the refreeze going. And now we are actually more or less on a par with 2012, where we was at this point in 2012. Very few years have done that over the past few years. And the only year that I can find that is close to this is also 2007, which is this blue line just here. But even that did move up, although it probably reached a lower minimum in terms of how much ice we lost. It did move up generally fairly quickly once the refreeze gathered pace. So I'm not quite sure what's going on in the Arctic at the moment, why it's taking such a long time to get the refreeze going. It could be because we've seen quite a lot of northern blocking so far. Particularly this October, might tie in with that, but the refreeze of the North Pole is taking a very, very long time to get going. And now we're going to focus on Siberian snow cover for the remainder of the video. So this was the situation across Russia and Siberia in terms of snow cover when we did the 5th update this time last week. Of course, this white area is where we had snow cover across the Siberian plain. By the way, the yellow area up here is Arctic sea ice. So that is all indicating the ice. But it's the snow that we're interested now across Russia and Siberia. That situation this time last week. What about the latest? Let's have a look. And we have seen some gains in terms of snow cover compared to what we had last week. So that situation last week. This is the situation now. Definitely there has been an increase, although not a huge increase over the past week. So let's see how this compares with past years. And I'm going to try and get us back to 1998 in a second. Sorry about that, so I've got us back to 1998. And this was the situation across Russia and Siberia in terms of snow cover at this point, middle of October in 1998. Now, comparing that with this year, 2016, you can see that we actually have more snow cover across Russia and Siberia at this point in 1998 compared to what we have now. 1998 is as far back as we can go with the archive at the National Ice and Snow Centre, by the way. This is 1999, I think pretty much on a par with where we are right now, maybe a little bit more compared to where we are right now, if anything. 2000, I think we're above 2000 in terms of Siberian snow cover right now. Not a great deal in it, but we are a little bit ahead of the year 2000. Probably on a par with 2001. 2002 has much more snow cover at this point across Russia and Siberia compared to what we have right now. 2003, we're ahead of those three, most definitely. That was a very, very slow start to the Russian and Siberian snow cover season. I think we're behind 2004. That looks quite clear. 2005, we're probably on a par with 2005, maybe even a little bit ahead of 2005. 2006 had more snow cover at this point. 2007, we're ahead of 07, quite obviously ahead of 2007. 2008, probably on a par with 08, maybe a little bit ahead, not a great deal in it. 2009, we are ahead significantly of 2009. I'm going to talk about that year more in a moment. 2010, perhaps on a par with 2010. And again, I'll talk about that a little bit in a moment as well. 2011, I think we're ahead of 2011. 2012, yes, I think we're ahead of 2012 at this point. 2013 had more than we've got right now. 2014 had a lot more than we've got right now. And 2015 had more snow cover than we've got right now as well. So in terms of where we are with Russian and Siberian snow cover, we're probably still somewhere in the middle. I talked about this last week. I think last week I said we were somewhere in the middle of where you would expect things to be in terms of the advance across of snow across Russia and Siberia. I think we're still more or less there. Maybe slip back a little bit more. There's perhaps a few more years now that are ahead of us compared to what we had this time last week. But overall, not particularly exciting either way. Now, a few people have asked me about this thing, so I'm going to talk a bit more about it now. What's perhaps apparent there is that a lot of the years that do very well for Russian and Siberian snow cover are not cold winters in the UK, or don't have cold winters following them. For example, 2002 did very well. 02-03 wasn't a particularly cold winter. 2013, 2014, and 2014, 2015 did very well for snow cover. How quickly advanced across Russia through the autumn. Again, weren't followed by cold winters. There's an area that's more important, actually, than Russia and Siberia. I do like to keep an eye on what's going on across Russia and Siberia, but there is an area that's perhaps a little bit more important, and that's Scandinavia. So this is 2009. This is this point in 2009. Notice there's very little snow, actually, across many parts of Russia and Siberia out on the 15th of October 2009. What snow cover there is tends to be in the northern part of Russia and Siberia. But more importantly, look how much of Scandinavia is covered with snow cover at this point in 2009. That's the area that's more interesting for me, actually, when I do these updates, than Russia and Siberia. As I say, I do like to see how quickly the snow is spreading across Russia and Siberia, because if it spreads very quickly, I think it translates back to an increased strength of the Siberian high. And of course, a lot of those winters that weren't cold winters for us, they did still have a strong Siberian high. But what happened in those winters, say, a very good example is 2013, 2014. What happened is that instead of the Siberian high going that way and giving us cold weather, it actually went that way over the pole and down into Canada. So it did still have an impact. How quickly that snow cover advanced across Siberia and Russia did still have an impact in winter of 2013, 2014, but the impact was for very cold conditions in North America. And the knock-on effect of that was actually to give us a mild winter. So, because it enhanced the jet stream, blew up the jet stream in the Atlantic, that gave us a very stormy winter, 2013, 2014. So, the Siberian high was still strengthened by how quickly the snow cover appeared across Russia and Siberia. but it went over the pole and down into Canada as opposed to moving through Russia and into Europe. So it's Scandinavia that I am particularly interested in when I do these updates, getting snow cover across Scandinavia. We had an early snow cover in 2009, October 2009, before that cold winter of 09. 2010 also had some early snow cover across many parts of Scandinavia. This was 24th of October 2010. You see quite a lot of snow in Scandinavia then. 2011, now this is a year that doesn't have much snow cover across Scandinavia. This is 24th of October 2011, and you'll notice that away from the mountainous regions, we have got some white splotches here across Scandinavia. They're the mountains of Norway, but away from mountainous regions, hardly any snow across Scandinavia during October 2011. That's a mild winter, of course. This is 2012, our last cold winter. Now, that was a very interesting year for snow cover across both Scandinavia and Russia. This is a situation on 23rd of October 2012. Notice probably lagging at that point in terms of Siberian Russian snow cover, but quite a bit of snow across northern central parts of Scandinavia. Look what happened, though, as we went through October. Very rapidly, that snow cover advanced through the final week of October. So by the 30th of October, we've actually spread the snow cover out of Russia and into Europe, which was really unusual, and covered most of Scandinavia with snow cover. And that's the last time we had a cold European winter. And of course that went on into that really severe March as well. And I think how quickly the snow cover advanced across that central western part of Russia and also impacted Scandinavia through 2012 was an indicator that the atmosphere was doing something quite unusual. 2013, however, that didn't have a great deal of snow across Scandinavia during that year. Now, 2014 perhaps blows the theory out of the water a little bit, because that had a very rapid advance of snow cover across Russia and Siberia. This is 22nd of October 2014. Did also have quite a bit of snow cover across Scandinavia as well. That was the year of the OPI. I'm sure you remember it, the October Pattern Index. And what the OPI was attempting to do was really to quantify the weather patterns that were causing that snow cover across Russia and Siberia and also Scandinavia. So the OPI was negative, and that was telling us we had blocking through about October of 2014. And that blocking is what produced the snow cover. So in some ways, the OPI, what I'm doing with looking at Russian Siberian snow cover and how quickly snow cover appears across Scandinavia, it's kind of the same thing. But I was never all that sure what the OPI was trying to quantify. But anyway, 2014 did have a very rapid advance of snow cover across Russia and Siberia. Also had an early snow cover across Scandinavia. The winter of 2014-2015 wasn't a cold winter. So this is but one element, of course, and I wouldn't use this on its own to produce a winter forecast. What the OPI was doing was just doing this one factor, this one driver, and then creating winter forecasts from it. I wouldn't risk that at all. I would like to put this driver, snow cover across Russia and Siberia and patterns that bring it about, I would put that with all the other things that were just discussed in this 6th update and then create the forecast. Because on its own, this isn't enough of a signal to be able to say yes or no, we're going to have a cold winter. But I hope that it helps explain a little bit about what we're doing here. It's particularly Scandinavia that we're interested in. I'm not particularly sure that it's the snow cover itself across Scandinavia that's important, because what normally happens actually is that the snow appears across Scandinavia in October and then you get into November and it melts as it turns milder. That certainly happened in 2009. It happened again in 2012. So not the snow cover specifically that is interesting in terms of winter forecast, it's the patterns that deliver it. And when you get a pattern that can deliver snow cover very early to Scandinavia, that can tell you that the atmosphere is behaving abnormally, and that can increase your chance, if it continues, of colder weather into winter. I've gone on quite a lot, and it's quite a complicated thing to explain, but I hope I've done a decent job of talking you through that one. Because of this, we haven't been able to put any analogues in for this 6th update. The analogues will return probably next week. James Ackrill is beavering away as I speak on the analogues, and he's got some very interesting data in terms of October blocking. So we'll start to discuss that perhaps next week, maybe after that. I'm not sure quite when that will be, but the analogues will be back very soon. Right, that is the 6th Winter 2016-2017 update done. And that one is out of way. A bit of a Siberian and Scandinavian snow cover special. Hope you enjoyed it. Later on today, as I said at the start of the video, we're going to have our next seasonal ECMWF seasonal model interpretation. That'll be with you this afternoon for around 2 p.m. on the ECMWF seasonal model interpretation page. I'll be posting the links to that across social media, so don't worry, you'll be able to find it easy enough. It'll also be on the links page. It will also be the link to it will also be on the homepage as well. So that'll be with you this afternoon. Hope you enjoyed the 6th Winter 16-17 update. This will be placed on the Winter Updates page later with that written summary, just explaining everything we've discussed in the video. But at nearly 36 minutes, gone on far too long again, sorry about that. That's all for now, and thanks for watching. Come back for the ECMWF interpretation later, and the 7th Winter 16-17 update, same time, same place, next week. That's all for now.